Now is it okay? Okay.
Yes, we can hear you now. We can hear you now.
Okay. Okay. So, hello everyone. I'm Karina Bonjongwi.
Oh, okay. Okay, pardon me for not getting that right, please.
No. It's not easy. Even if here, it's not easy to pronounce it. Bonjongwi.
Bonjongwi. All right.
Yeah. It's not easy. So as I said, hello everyone. I'm Karina. It's better to say Karina, even if you can't pronounce Bonjongwi. That doesn't matter. So today my presentation is about big data. We talk about challenges and opportunities. So this is the structure of my presentation. I will first introduce what is data science and big data. Then I will cover evolution of data. We talk about, give some example about use cases in industry with IBM in Africa. And I will talk about data protection and impact of hardware progress. At the end of all, finally, I will briefly present opportunities and risk. So I don't know if I know that everyone today use data, but maybe we don't know what is data. So the question here is, what is data? Data is just a simple description of reality of fact. For example, of data, we can have a message. Text message is a data. A list of hospitals in the world, account statement, list of cars in a car park, or a kind of transaction. All of this is data, our data, sorry. So data can be simple and taken in isolation, not very useful, or can be complex. For example, if we have a satellite image. So when we have data, we need to extract information. So information is simple, obtained from interpretation and analysis of a data collection in order to make sense in the context. For example, we can have a state of account for a given period or all grades of students in the year. So it's very useful to understand what you are doing, what kind of information you can take in or to prune. So this is a simple autonomous marker with two axes. The first one, we have a context, and the second part, we have understanding. So the first part, we have a data. By using this data, we can extract good information, okay, in order to solve a problem. Based on this data, taking into account the context, we can take knowledge in order to take into account some matters or some programs for the future. Maybe in order to recommend the best customers in 2022. So this is data and information. It's about the past experience, and the new one or the future, it's about knowledge and wisdom. So it depends. It's about researching. What are you doing? We need to observe or to doing something in order to correct some programs. We need to interact or to reflect. So depending on the context. So what you can say about this autonomous marker, it's the more you have data, the better you can understand what you are doing or to solve your problem. So what is wisdom? Because I talk about wisdom. Wisdom is just a ultimate level of understanding some situation in order to make a better decision. Knowledge is just a complexity of experience, and what you said about information is the extraction of data by taking into account what you need to take. So you need to prune what is not useful. So every time since already, I think 5 years, we are talking about data science. So what is it? Because today we talk about big data, but how could we give or to make sense of this data? Data science is a science making sense of data. So it's a set of many parts of science. For example, in data science, we have statistics, we have machine learning. We need to know how to manage data, to visualize data, to collect data, to clean data, to integrate it, to process, analyze, and visualize the big data, because about visualization, we have many parts. So the goal of this is just to create a data product and data services. It's important to know that the data scientist is not the data analyst. So the data scientists need to have a strong technical skills about statistics, machine learning, big data analytics, and a good knowledge of a business domain, because data scientists need to interact with others in his services or in our services. So today it's hard to find a data scientist. Why? Because a new training programs are over the world, but many fake data scientists on the market. So now I will talk about big data. What is it? Big data is a buzzword. So when we see the definition in Wikipedia, they say that it's just a set of data, but before big data, we already used data. But here, the matter is that the problem is difficult to process this data because of volume. When we talk about big data, we see 5 dimensions or 5 properties. The first one is the volume, because it's not about gigabytes. Now we talk about terabyte, petabyte, exabyte, zettabyte. So the long markets need to produce a new kind of products. For example, Oracle or Microsoft try to improve their products in order to process this kind of data. So why this data is big? As I said, today we have a big amount of data. We have many networks, devices, and all of these, for example, with our mobile devices, we transform data, we use data, we produce data. We have today a kind of sensors, satellites, so all of these produce data. So we need to take into account and to increase storage capacity, because in order to process and to take into account the scalability. So I talked about big data dimensions. So now I will go into the details and say, what is it? First one, we talk about volume. When we talk about volume, we refer about amounts of data. When we talk about these amounts, the problem here is that it's difficult, first one, to integrate data, to manage data, and also to analyze it. The second part is about velocity. For example, when we have your sensors, we need to take into account, for example, how many devices you have in your house and over house, and to see if someone come in your house in order to call police and to see how they can react. So these sensors we take our information, but right now. And all of these need to be continuous and process quickly. So the difficult part here is that it's hard to perform online processing. Another part of this dimension is variety. We have different data formats. For example, we can have image, a kind of voice message is not the same format. We can have a text message is not the same. We can have a SQL format, for example, about the SQL is a kind of structured data. So all of this is good, but the program is about semantics. We have different semantics. We have different syntaxes, and we can have uncertain data. So all of this makes it hard to integrate and analyze data. Another part of the dimension is veracity. If I have one profile on Facebook, how could I know if Carolina, what I can see about Carolina, her age, the country, her address, mobile phone, and others is correct? I can't know. So every time when I process my data, I need to check if what I'm using or what I'm analyzing is correct. So it's about authenticity, conformity of data with reality. Because sometimes you can have a fake news. Okay, so we have another part, the last one, it's a validity. So if our data is not correct, we need to correct this and give a kind of accuracy of data, for example. So we have big data, but we need to find useful information and to discover knowledge in data. It's the goal of big data analytics. Big data analytics enable to find useful information and to discover knowledge in data. For example, we can do some predictive analysis in order to have a better decision, for example, to make some research in some area. But why all of this is hard? It's hard because we have low information density. We have various sources. For example, we can, for text data, we need a source. A kind of source can integrate with kind of data. For images, we need another kind of sources. So all of this is difficult to know what is better, what is the best, and how could I process it. Another thing is that we have different kinds of data. We can have structured data, for example, transaction, scientific data. We can have unstructured data, for example, web document, open data, IoT, and all of these it's become difficult to integrate all of this. So another part, I will talk about some application were called BDA, so big data analytics killer application. Because we talk about big data, so we have many industries, and some industries already use BDA application or produce a BDA application. For example, when you need to recommend with Amazon, when we need to recommend some articles, for example, you buy your laptop and they can recommend you to buy a flash disk, for example, and say that if you buy computer, your laptop plus your flash disk, for example, plus a small router, all of these can the cost of all of these can be 10 or $25. We can use it, we can have some application about online fraud detection. For example, for e-commerce, banking, telephony. Another kind of applications, it's about national security. For example, for cyber analytics. And the last one is about medical science. So we talk about data, information, big data, data science, big data analytics, and all of this, but we need to know something about evolution of data. So today, data is interconnected. How? We have more and more interconnection of data and information. For example, with web, we have connection between documents with hypertext, social network, RDF, and linked data. So I will talk a little bit about it. What is hypertext? It's just a document or a set of documents. It consists of information units linked by hyperlinks. So here we talk about wiki. Wiki is based application which enable creation, editing, and collaborative illustration of pages within a website. I also talk about blog. So it's just a type of website used for periodic and regular publication. I talked about social network. Maybe we know what is it, and it's enabled to interact between us, for example, by sending messages, comments, songs, images, all you need to send. So I also talk about a resource description framework. RDF is a family of World Web Consortium. For example, it consists of three parts. When you have RDF, you have subjects. So for example, here, this one is a subject. This one is a predicate, for example, age, and we have some object. So it's just what I can say about it. Quickly, I will talk about ontology. Ontology describes, it's the description of knowledge. For example, when you have music, these concepts can collaborate with many knowledges or some domains, for example, or some words. We can collaborate it with timeline, with chords, with instruments, with studio. And in studio, you can have a device, multi-track, audio effect, microphone, and whatever you want. So the last thing is about linked data. For example, we can see here we create typed links between data from different sources. We have DBpedia. With DBpedia, we can have it daily made, open colors, eServe, and all data linked with this DBpedia. So last time when I talked about velocity, I said that we have a continuous data. It's fast with a time-varied data streams. For example, of this, we can have a stock prices or a news. It's a kind of data streams. But the problem of using these data streams is that it becomes difficult to analyze data in real time. For example, the question is, when you don't have a time to store this data, how could you process it? Or how could you integrate it? Because in your company, you can have many profiles. So which user can use or to integrate data, to process data, to analyze data. And another part is about infrastructure. So after talking about data streams, we talk about another kind of data, IoT. So what is IoT? We use many devices. For example, sensors, connected watches. So IoT is just the Internet of Things. It's a kind of interaction and interconnection of all kind of digital objects via internet. So these objects enable us to give us, for example, a kind of identification with IP address. We can transfer data. We can communicate by using wireless communication, for example, Wi-Fi, Bluetooth, or RFID. So quickly, I will give you, so now let me give you the big picture of data-intensive science. Okay, here we have some observation of data. We observe data by using a satellite, the mobile phone, and we have a web data. In this web data, we can RDF, so what I explained before talking about data-intensive science. We have some experimentation data. Inside, we have a platform about plants with some phenotypes. So we will collect all of this. Okay, the first part is to validate what we need in order to produce information and to extract the good knowledge. So after that, we will integrate this data. After integration, we analyze it and we try to collaborate all of this in order to produce information and the good knowledge. So the problem here is in the Office Science Data Management Challenge. They say that scientists are spending most of their time to see how to manipulate, to organize, to find, to move data instead of researching, because we have many programs, we have many solutions. So it's going to get worse based on all we are manipulating, we are organizing, we are finding or moving. So the next part, I will give you some examples or some use cases about big data analytics. Here you can see some industries, for example, about telecom, retail, healthcare, government, and different use cases. Here we have data types. You can see that, for example, about telecom, when we need to call detailed records, some of them use geographic and machine data type. So about infrastructure investment, they used server logs and machine. So we have different data. It depends on the use cases and industries. It becomes difficult to process it. I can give you another kind of use cases. For example, quickly about big data exploration. Here, IBM needs to find data, to visualize it, and to understand the different data. Another kind is about recommendation, how to recommend or to satisfy the customer by giving a best way to buy, for example, some articles, or to produce or to provide a new service. Okay, we can give another example of use case about real-time security. For example, about social network, we need to detect fraud. We need to extend some part of security, for example, by keeping some data or some information of user or always secure, or by trying to secure data. Okay, so we can have analysis of operations, some modernization of data warehouse. In Africa, South Africa, or precisely Cape Town, they have a problem. The challenge is that they need to help farmers to make the best decisions about irrigation, pest control, and fertilization. So the solution here is to produce a database of agriculture data. Inside that include climate, soil information, and disease from open data sources in order to provide a cloud-based analytics solution. This enables to promise and to empower agriculture industries. And the results here is that the solution helps farmers to triple or to quadruple their production while optimizing irrigation and saving water. So they have another one in Kenya, but I didn't put it here. It was about Ebola. They tried to track the person who have disease and to put all of them together in order to give a good drug before enable them to go to his or to her house to see her family. It's the same thing, for example, with the COVID here. So when we talk about data, we need to protect company and to protect the user of his company. Here in Europe, they provide a kind of general data protection regulation. And this one concerns any company, even if a small or a big one. So if you don't take into account of this regulation, we pay 20 million of euros. So the goal here is to strengthen the right of person whose data are processed. For example, the right to, we give them the right to forget, reinforced consent, easy access. They can control data to see what the company are doing with our data or his data. And the principle here is the obligation to ensure that processing operation complies with the rules laid down. And we talk again about privacy, about confidentiality, security requirement. All of this requires good data governance. So I will talk about impact of all of these on big data. Sorry. We have some advantages and drawbacks. About advantages, what I can say, obligation to ensure that the processing is in conformity with big data. It's mandatory. It's mandatory to build trust with users. And about the drawbacks, that the company need to add cost and complexity because we need to buy some softwares to buy new devices in order to secure data. And when we process, we have some difficulties because if we anonymize data, how could we extract the good knowledge or to identify the person who are using this account, for example. So it's become difficult because we can have a kind of bad information because of anonymization. So I talked about big data, talked about data processing by using big data analytics or data science. I give some use cases. Now I will talk about impact of hardware progress. So where we talk about hardware progress, we need to take into account the storage. The last time we talked about maybe in 2000, we talked about SSD kind of storage, but now because of the amount of data, they replace all of this by using HDD. We also see improvement about memories, about multiprocessing because we have many tasks. We need to parallelize the task in order to process all of these quickly. We have some improvements about the broadband network too. So about in-memory, the disk was very slow. So now they give opportunities to have more memory, and by adding, for example, some parts in order to process all data in memory processing. For example, by using Spark, we can enable our user or our data scientist to make in-memory processing. Quickly, I will talk about another part, the processor we use. First time is kind of central processor. Now they're able to combine the advantage of CPU, it's a simple central processor unit, with a graph processor unit in order to transform or to process very quickly and in a few time data. We need to parallelize data by using more processor, more memories, and sometimes more disks. So here it's a small graph in order to see the link between scalability and parallelism. So the early days we have this kind of machines. Nowadays we have this one in order to process, to analyze, to manage data. When we talk about big data, we talk about landscape. And this landscape consists of infrastructure, this part, all of this. We have some softwares about analytics parts, applications. We have some software we combine infrastructure and analytics. We have some open sources data sources. So for example, for those who are using, who try to do some visualization, then can use some software. Here, for example, Tableau, Kitenga, ESS. For those who are using, for example, analytic services, they can use Opera and whatever. So it depends on the goal or the your need, and your goal. So if you know you need to do some to manage your data, and this data have different formats, you can use NoSQL databases. If, for example, you need to do some statistical computing, you can use, for example, SAS or Mixlab. So it depends on you. But the problem here is that it's easy to get lost because there are many solutions, no standard, and all of these are in constant evolution. So it becomes difficult because even if you are data scientist or big data analytics or data analyst, you can't know all of this, all solutions, because it depends on your company, what they are using. So about big data, we have some opportunities and some risks. Because with this large amount of data, with velocity dimension, with variety of data, with what I can say it again, variety of data, with validity of data, we have some opportunities, for example, about cost reduction, because now, as we saw here, we have many technologies for different programs. Finance, government, finance, for example. So I need to change. Finance, for example, is here. You can use LandUp. For regulation, you can use PredPol. For security, it's possible to use FISA. About cloud real-time or big data search, we can use some product produced by HP. So there are many technologies, and some of them are open source. For example, Spark, in order to process your data quickly, your distributed data. You can use some technologies, for example, HBase, in order to store your data. It's possible to coordinate your workflow by using OSI. Possibility to use machine learning with Python, MLlib, with Maut. It's possible to do some searching by using, for example, SolR, but it's free, so it's open source. We have some cloud services, for example, with Amazon Cloud Services and whatever. Big data gave the way it's enabled to do a faster and better decision by using some online processing software or application. You can discover the best knowledge. You can use produce some products and services. For example, today we have Airbnb. We can personalize medicine to make digital agriculture, and whatever you want, big data give you this opportunity. So we have some risks about big data. The risk here is about safety. How could I be sure the data I have provide before providing this, one didn't come and take or transform this or change maybe one part of my data? How could I know if my devices or my laptop, my servers are secure? Okay. About privacy, my personal data, for example, by using Facebook, by using WhatsApp, what Facebook are doing with this, I don't know. Maybe they can sell my data. When I use cloud, when I try to store my data or to process my data, I don't have all information about the computer or the server I'm using. So all of this is become, there are a risk inside. Another part about the costs. If I want to collect my data, I need to take into account the processing time. So when I process, I need to take into account the time, because the time, I need to take into account the cost of aggregation, for example, the cost of storage, the cost of analysis, and the same one for reporting. Another risk is about analysis. Sometimes, for example, if you write something in Facebook, you try to use Facebook, you put the name, Facebook will analyze but give you many names, okay? And I'm not sure that the name I'm using is the correct name. For example, if I click on Carolina, inside I can have many Carolina. It's the same thing when we use some machine learning algorithm. So the representation can be difficult because we can have some mistakes. The conclusion can be bad too, because if we interpret, the interpretation is not correct, the analysis can be incorrect too. Another part is about when you use a big data, you can have a bad data. So today we have several open data. We have several databases, but what is the good data you can use in your project? And when you collect this, you need to prune the wrong data, you need to prune the useless data, and to prune raw nails data. So all of this, you need to have a good knowledge about big data analytics, about sometimes statistics, about data management, processing, analysis, and whatever you want. So it's what I can say quickly about big data, opportunities, risk, and some impacts linked with big data. So if you have some question, I can go into the detail of some part I have quickly explained. Thank you.
Thank you, Dr. Carolina. So you want to pause now for some questions, or you want to wait till the end of the presentation for questions?
I can start with a question. You can start now.
So
Just
do you have
this
any
part.
questions?
Yeah.
Just very briefly, does anybody have any questions
Okay.
so far?
Okay. Okay. So I will talk now about big data challenges and opportunities. We need to know how we can store data. So I will talk about NoSQL very quickly and SQL. We have several formats. So how could I use, how could I store this data? And when could I store this data and manipulate the data? Okay. So I talked about NoSQL, about data. What is the motivation of all of this? The properties linked with this new kind of databases, management databases. And I will give some information about NoSQL. I know that here we have some computer scientists maybe, but I will go quickly into the detail. And if you have questions, don't worry, I will ask without going into the detail in order to avoid some confusion sometimes. So this part, I kept the name of my supervisor because I did this presentation in some big data school. So I signed one paper to say if one day I want to talk about this part, I need to keep the name of my supervisor because it's not just my work. It's a part of my my thesis, one part of my thesis. So every time I talk about it, I need to mention his name. So the motivation here, it's as I said, we have the new trends. First, we have a big data, and inside we have different type of data. We need to take into account the scalability. For example, when you process your data, you can have many users, okay? Large amount of data. You can have different type of data. So even if you have all of this, your machines or your applications must work. It's the goal of scalability part. So before talking about the new kind of data, what now the data scientists or big data analytics talked about NoSQL. Before of this, they use a kind of structured data. For example, this data, we have two parts. We have a kind of columns, okay? It's structured, all of these are structured. We have a columns and we have a kind of rows. So we have, for example, we can have, I will give you one example very quickly. Okay, for example, we can have some part of about students. Okay.
Okay, you're on mute, Kalina. Okay.
Okay, thank you very much. Okay, so for example, we have something about students. With these students, we can have many informations. For example, ID. Okay, we can have the name, address. Okay, another thing, for example, the city. Okay, so the most important thing here is that when you have ID, you can have, it's not possible to have ID1 and another ID1. No. When you process, it's just one ID. So one ID1. Just one ID1. For example, the name, I can take city, for example. I can take Abuja. Sorry. Address, what you say. Name, for example, Ebelo. So I have another two ID, we have a new name, for example. Natu. Sorry, Natu, for example, new address, and from Benin, for example. So this one is about rational databases. So it's this one. Before talking about big data, they use this kind of structured data. So this one is a column. We have one column about ID, the name, address, city. And we have some rows. Rows one. In these rows, we have one as ID, below the name, address, city, Abuja. Another row with value 2 about ID, Natu about the name, and city, Benin. Okay? So the problem here is that if you want to need this kind of databases with structured data, you need to have a good skill. Okay, because the schema here, the schema is how you can describe your data. So this one, my data is structured. So I try to describe my data in a kind of table. So my table name is here, students. So the problem here is you have your data, but you need to process it. But by using this kind of databases, it becomes difficult to process your data. If you want to use, you need to use, for example, some kind of new techniques, and this kind of techniques you need to do so many inputs and outputs. You need to take into account the costs of computation. You need to take into account the time cost, and it becomes difficult because of many things. So another part is about update, because, for example, if I need to change just a small part, I need to change, I have 1 tera of data, okay? I need to shade my data. For example, to say this first part, I will keep it in one node, so one computer. Another part in another node. So it becomes difficult to do all of this, to process your data, just simple. So I have one example. Okay. For example, I have a client in Nigeria, okay? There is not a kind of data here, done. So my client sent me data. This one, I have a kind of server. It's just enable, the server enable, for example, to keep your data. The client can be a company, society, what you want. The load balancer here is to share your data, what you will provide. So it's the goal of load balancer. The server will keep your data, we try to process it you want. We have here a master data. Master data base here, give instruction. So take the data from application server and try to replicate the same data, to process it and to replicate the same data in the slave. So I have one client, for example, here, Nigeria. I have another two, so precisely Abuja. I have another, for example, in Nigeria, okay, in Lagos, here, a client. I have another from Benin, okay? So if I have many clients, I need to add another server in order to take into account scalability, because the charge, I increased the charge. So I need to take into account of this and to add another server. But if you add another client, you now add another server, so another server, it's become difficult because the database will become the bottlenecks. So you can have some failures. The goal here, they say that we need to avoid this bottleneck, and we will propose another kind of databases, okay? Because we can have a document database for those who are using, for example, can store our data in MongoDB. For those who are trying to do recommendation, they can use a kind of graph databases. For those who are using a column databases, they can use, for example, HBase and whatever you want. So all of this, it's enabled to improve the process and to avoid bottleneck. So now we can talk about scalability. We can talk about extension scalability because we have many data, we have many processing parts, or we have many programs or needs about the client side. We can process all of this. The limit here is about consistency, because we have different structure of data. They can be a kind of text, songs, movies, whatever you want. So we talk quickly about the changement or extension of a new product or extension of a new way in order to process our data. So all of this, it's linked with, all of these are linked, with new theorem. So the theorem is called CAP. This CAP is different of the first theorem about database. So quickly, I will talk about this theorem. So why C? Because we have a distributed system now, because we don't have time to wait for, if, for example, if I want to process my petabyte, I don't have time to wait for 5 months. For example, if I have my customers from Amazon and they want to process data and to recommend a new product or services to their clients, they don't have time. So I need to parallelize time to use a distributed system in order to process all of this very quickly. For example, in 5 days or 2 days. So this theorem, we can describe it. C is consistency. So we have all nodes. The node is just a machine to help you to compute your data if you want. So all nodes see the same data values at the same time. We need to take into account availability. So requests get an answer. Your request can, example for to be, for example, I can take, you have your students and you are a client, you ask your system and you say that I need to know how many students I have in my classes. This one is a request. It's just a kind of query you ask or answer you ask to your system, because your system already have all information about what you are asking normally, because you store it. So the first one is you need to take all your data to prune what by using your database management system. So they will help you to store your data, to manage your data, and maybe to analyze what you want. So the partition tolerance is about the systems. So even if we have a network failure, the system keeps functioning. So this theorem is proposed by Gilbert and Lynch from MIT. But this CAP is not possible to have all properties in the same time. It's not possible with a distributed system. Why? Because all nodes can see sometimes the same data values at the same time. So based on this, they say that we can share this consistency in 2 parts or in 2 ways. The first one will be a strong. For example, the strong consistency, here I have my client. This client have a data about students, for example. And this one have data, for example, about a professor. Okay, and here we have students too. Here we have a professor. Okay, so if we have this data about consistency, it means that if it's strong consistency, it means that DB1 can see the data, can share the same information. So students and professor. The same thing here, professor and student. This one is the strong consistency. So about the eventual consistency, what I mean by this, what I want to say is that here they can't share data. Okay, we don't have the same information, students and professor, we just have information about students here and just about professor here. Okay, but we talk again about another part. So this one is about consistency. We can have two kinds of consistency. Okay, so the node here is just a database. The database enables to store your data and to manipulate it. Okay, and we can have one database for one part, for example, node 1. Okay, computer. Another one to node 2, for example. So they can share in the strong consistency. But if you have another problem, for example, here you have a kind of failure network. If you have your failure network, about the CAP theorem, so C for consistency, we say that we have two kinds of consistency. This one is about availability, and other one is a P, about partition tolerance. So now the two databases can't interconnect. So here about E, it's okay because client can continue to process his data here in the node 1. This client 2, though. So I have, for example, client 1 and client 2 can continue to process the data in different nodes. But the problem here, they can't share the data. Okay? Their knowledge, or sorry, they can't share informations. So what you can say is, based on two kinds of consistency, here we have inferential consistency. So if we try to improve the program, we can reconnect and then have a strong consistency. So I talk quickly about NoSQL. NoSQL, NoSQL, sorry, it's not only SQL, because before we have a kind of structured data. I talked about this when I give an example here about relation data, for example, about ID, whatever you want. So with a different formats, we have different approaches. We have a different data model. A data model is just how our data is, our data are storing in our databases. So we can have here, for example, a key value. I will give you one example very quickly. We can have a tabular, we can have a document, we can have a graph database, and kind of multi-model databases. So very quickly, for different databases, we have different manner to process the data. So we have, for example, about key value data stores, we can have a Dynamo. Dynamo is an Amazon product, data storage. For example, I have many information about forum thread. So I call it the table, it's just the name. But in this one, I have information about forum, some subject, date of lab post, and the tags. The different parts, for example, here we have a key, okay? We will see that in this example about this data model, we can have the same hash key, S3, S3, S3. But about the first slide, I gave you one example about students, and I say that it's not possible to have the same key. We need to change the key because it's a kind of constraint, integrity constraint. Okay, and here we can use some methods or some query. For example, if I want to get an item, so about the forum, I asked to my system, sorry, I need to have the forum, information about the forum AC2 and link it with subject X, Y, and Z. So what the system can do is to come in my table named forum thread and check where is AC2. Here I have AC2 with a subject, ABC, okay, with a date of last post, the tags. Here I have the same thing, AC2, but this one is not, I don't need it because here what I want to know is just, sorry, what I want to know, sorry. Okay. Okay, so sorry, because what I want to have is just the forum AC2 and this subject. So when I saw this table, which parts of my table answer to this question is just this part. So at the end, the system will give me all of this. The forum EC2, subject X, Y, Z, the date of last post, the tags. We can have another kind of question I can ask to my system. For example, this query, I need to have this forum S3 and the subject need to have A and C inside of the subject. So the answer will be I have this one. For example, about it, S3, this one is correct. I have S3 here, I have S3 here, I have S3 here. Here, my forum, is it S3? No, I don't have it. So I will prune it. Here, EC2, no, it's not S3. I don't need it. Here, do I have S3? No. So this part, I already prune what is useless. Next, I need to have in my subject A and C. First, here, do I have A and C? Yes, it's correct. Here, do I have A and C? Yes, it's correct. Here, do I have A and C? No. So the answer will be this one. Okay, so this one is the kind of query, the question I can ask, sorry, to my system. But in order to ask this, to write the query, I need to have some knowledge about DynamoDB. It's a kind of key value. So now I will talk quickly about another kind of data model. It's a tabular database. It's called HBase. Sorry. No, first I will talk about document database. So when could I use these document data stores? For example, when I need to manage a document systems, I have a content management system, I have catalogs, I need to analyze some messages in real time, and I have some database for web server, and I must handle JSON natively. So in this case, it's better to use document data stores. We have many kinds of document data store, but here I will give you just simple example of one data store. It's called MongoDB because in many companies they use it because it's more easy. This one is a kind of structure of data we can have. For example, here I have a book. So I have my Bib bibliography. I called it Bib. Here inside I have a book. I have a title for each book. So I have, for example, book 1. In this book, I have a title. The name of the title for this book is Principles of Distributed Database System. And with the authors, I have here 2 authors, Patrick and Tamer Ozo. The name of the publisher here. I have another book, title is about XML, publisher here. So about it, I need to collect it and put all of this in the database. I will give you another example. You see here, we have a different format. Here we don't have it. We don't talk about the key range, about the art range, and whatever you want. What we talk about, what I mentioned in DynamoDB. So we have automatically a unique key, okay, generated automatically by MongoDB when you collect your data and you store your data automatically. If you didn't put your data, MongoDB will give you a unique key. And this key can enable you, for example, if you have 1 tera of data and you need to search for your data, it will be very easy by using your key because it's unique. So with this one, we can process data by using another kind of query. We can select your data because I gave you one example about this over collection post, with some information, for example, about overs. Here the name is Alex. The title, no free. We have a text here, for example, this is a good year to start business. We have some tags, business, numberings. We have comments. We comment the text, for example, Jane, they say that I agree. Joey gives some comments. They said no, I don't want to know more about it, for example. So it's possible with this, about this database, so DB, we have here the name of a collection, what I said is post. We can process it, so by inserting some data, updating, for example, here, if I insert, I already have order, so I need to add a new order and say that I need to add this title, no free lunch. Here, I need to do some updates. For example, to add a new age and to push a new tags, for example, musical. So it's possible to find all posts from Alex by putting this syntax. To find, for example, all posts commented by Jane by putting this one. So DB, the name of a collection. The name of collection is this one, posts, okay? And find, it's a function. This function will enable to see the properties we need to visualize. So we have many kind of database, document database. So we have here different vendors, products, the languages. We saw that it's different because here is JavaScript. Here we have JSON and different parts. We can have some about comments. I put open source. Over that can integrate with different data processing framework. For example, with Hadoop framework or Hadoop database. So I have one case study about the document databases. For example, I have an structure or company. It's called Choosing Bus. They provide a kind of B2B platform. For example, if you want to share the bus with your colleague, you have some tribe, and you need to go and visit Abuja with your classes or with your colleagues. So you can share the bus, you can, okay, do what you want to, or with your family, you can go and it's a kind of Uber-like. It's like Uber, sorry. So the problem here, there have many clients, customers. So it's become difficult to store the data because they have different formats. And we need to process dynamically or to schedule dynamically the bus. So it becomes difficult, for example, to check where is the bus, okay, where is the bus, and how many persons took the tickets and what you want. But they propose to use, in order to provide a good solution, they propose to use MongoDB, a kind of document data store, okay, because we need to process requests about customers, for example, to know how many agencies we have, how many companies collaborate with this company, to check about location, about availability about the buses, and for example, to use Google Maps. So here I have some architecture, how we define. So for example, we have here the bus, we have a Google Maps, we have a travel agency. So first one, we will set the bus status, okay? And by using this threading, after that they can confirm order. If a traveler agency, we need to confirm order. Before this, they need to set travel information, and after that to confirm order if it's available or not. So inside of this, the system will enable to make the bus scheduling by using this bus scheduling system, and to process some information about the customer. For example, if we want to enable the customer to change the date, to buy another ticket for a member of his or her family, so whatever you want. I will quickly talk about another kind of database. It's called your Etablock database. So based, all of this is all stores are based on Google database. They called Google CBig Table. So this one is a data model. How we can represent this database. You see that it's different. It's not the same thing with document or key value data store I gave you. So for example, here, what we need to know, we have a row ID, okay? We have a column, and we have a column family. So it can be, we can have many information, even name, many information about the column family. So Netflix used this kind of database in order to process the data, because one day Amazon sent a message to a client from Netflix and say that we know that you have a terabyte, you have a billion of requests per day, and you need many nodes. So today we need to process or to change something in our system, so you can't process your data. But when Amazon did it, try to improve their systems, there gave some problems. So because you need to reboot the node. So Netflix lost a large amount of data. So based on this, they reflect and say that we need another solution, because every time Amazon need to reboot the nodes, it's not correct because we lost our data. They propose to use a new kind of database in order to process their data quickly. So this database is a Facebook database, so it's inspired by Bigtable of Google. The advantage of this, they don't have interruption. So always you have data, always we can watch your movie, always you can process your movie and to see how to fidelize, how to keep your customer, their customers, right? So we have another kind of graph about NoSQL in big data. We call it graph database management system. This graph database management system are used when you are processing social networks. For example, you need to make some recommendation, to do some sentiment analysis. If you want to manage some kind of data, for example, about data governance, you need to make some fraud detection in real time or impact analysis, management to manage some groups. It's better to use this kind of database. So the problem here, when we talk about big data, we need to talk about distributed system. What is distributed? We need to share the data in order to process it quickly. But the matter here, for example, we have a node, okay? And for example, node 1, we have here, for example, node 2, for example, node 3, node 4, and others. But we need to partition all of this. It can be possible because if you share this part, okay, for example, here we have node 1, 2, 4, 5, okay, 6, 7, 8, 9, for example. So if you try to partition this part of graph to put it in one part, so one node, big node, and this one to another part, 2. If you share, you will lose information. You will, sorry. Okay. You can have information, for example, about this node, because this part here we have another properties. So it's not possible to partition this kind of graph. So the goal here is a kind of NP-hard problem because we don't have we don't have a kind of optimal algorithm. So the solutions is maybe to use some heuristics, some approximate algorithm, or based on the graph topology. So I will talk quickly about Neo4j. Okay. Here, what we need to know, first time, this data model is different of others. When you want to know, is just, for example, here I have 3 parts: nodes, links, and properties on nodes and links. So what is links? What is nodes is here? Here I have 3 nodes. First one, it's about Bob. The second one, it's about Mary. The last one is about group Teddy's. I have properties, some properties. Friends, it's the first one. For example, number of properties, links, and other properties. So in order to have this kind of graph, I need to write a kind of code. For example, for those who are using Python, for those who are using Neo4j, it's this code you need to use if you want to create your transaction about node. Here, I will create first node, and I set a property. I say that my node inside, I need to see a name. The name is Bob. Age is 35. Okay, I create another. So for Bob, it's okay. I create another one. I say that I have a name, age, and job. So it's correct. Name, Mary, age 29, engineer. Relationship between Bob and Mary is friends. So this one enabled to create the relationship, and the commit part we enable to validate my transaction. So I can ask the question to my database system, for example, by saying that
Hello, Doc.
So I have a node. I will say that I need to match all friends, the friend of, for example, Bob, and the name starts by M. And after M, we have another part of later, for example. So this one, there is one case study integrated
Hello,
to
Dr.
Facebook.
Kalina.
Yeah?
Yeah, I just want you to be aware of the time.
Okay, it's already done. Okay.
Yeah, thank you very much.
Okay, thank you. So I have one case study about this kind of databases. One is used by Facebook. And what I can say about this kind of system, there are many products. So about the products, it's we give some identify different categories and different systems, for example, and based on requirements, you can know what you can use. For example, if you need to use a key value in order to access by key and to take into account some performance, it's better to use a key value. If you want to use, for example, you have a very big collections, it's better to use a tabular database. The graph, if you want to process efficiently your storage, and your storage are basing on some graphs, it's better to use a graph. And if you want to use, you have some transaction or you need to add the secret data in order to access with key value too, it's better to use a new CKS. So thank you very much, and I'm done. Now you can ask question if you have question.
Thank you very much, Dr. Kalina. So the floor is now open for people to ask questions, both from the first part of the presentation, right,
Okay.
and the second part, right? So if you have any questions, you can go ahead, you can add it to the chat. But Doctor, can I ask a question?
Yeah.
When it comes to graph databases, are they really very good to big data, so that the kind of data that you present to a GraphDB will be what is graph-like in nature, right? So I want to be able to see connections and I have nodes.
Okay.
But for the data itself, does it not have challenges handling a very large sets of data, right? That's my question.
Okay. If I understand, I can summarize and to give you one example about this one. For example, I will open my we start it. Start. Okay. I don't know if you see. I will share another part. Sorry. Okay, share this one. Okay. So, for example, here, this one is a graph database I'm using. I have some information about movies. Okay, so here you can see it's large because I have 35 nodes and 20 relationships. So here, even if it's large, I don't know if okay, here. Okay, so here they described different title and I have different relationship or whatever I want to see or to know about movies and actors. I have some characteristics, for example, voilà, some properties about different persons. But if I understand the question, Professor, it's if I have all of this, for example, I have 1 terabyte, how could I process it? Is it this question?
You are very correct.
Okay. Neo4j tried to simplify everything because here we can see the name of my labels, okay, the relationship tabs, and the properties keys. Okay, so directly, if for example I want to know who managed the part of an attraction, so when I click on this one, directly the graph I can see different node and the link between attraction. It's based on this relation named managed. And another part is, for example, about include. But in order to have this presentation, I need to write a kind of code. So this code can be this one. I will give you an example. For example, if I want to get all data and I put a limit, for example, if I have 100, I just need 10. Sorry. I will put this and directly they will give me this one. But before I need to collect the data and to store it. And in order to store, for example, I need to create my node. So if I do this one like that, I will create a node and with these properties. So in each level, I can know maybe with precision because with big data, before starting to process 1 terabyte, we will take just a kind of sample parts, for example, 100 elements, and we will check the result with 100, and if we check the result, it's okay. Now we can increase amount of data. It's like that every time we process, for example, in my company.
Oh, okay. So it should be incremental. That's what I get from that.
Yeah, incremental.
Okay. So there's a question here. I'll read it from Akintunde Ayodele. Since NoSQL has some obvious limitations, like you can't perform structured query on your data set, do you still recommend it, or what is the way around? So he's saying that NoSQL has some limitation. That the limitation is that you cannot perform data set. So would you still recommend NoSQL, right? And what is the way around not being able to do structured query? That's the question.
Okay, thank you for the question. So about it, I will go back to presentation. Sorry, I will share the screen. Okay. Okay, sorry. Okay, as I said, it's the same thing with a structured database. We have some limitations. So about NoSQL, okay, we have some one kind. This kind we can interact. We can try to do the same thing. For example, the kind of transaction we can parts like what we did in a relational database. But NoSQL is not there or are not there to remove or to say that SQL is not useful, because it depends on your requirements. It's what I can say about NoSQL. For example, if you have a graph database, it's difficult to pre-process it and to try to process it in order to structure it, to structure the data. So if you want to take into account some scalability, performance, because you can have your structured data, and if you don't want to use, for example, NoSQL, I can advise to use NewSQL, because NewSQL sets advantage of NoSQL, okay, and relational database. So they combine NoSQL advantage and relational database advantage. Okay. So another things about NoSQL, I can say that today you can see I'm talking. It's a voice. You are trying to save what I'm saying, but how could you process this kind of information with relational data? It's not possible. If, for example, you are using information, we try to collect data, Facebook data. How could I process this kind of data with SQL? It's not possible. And some relational database can't process, I didn't say all of these, but some databases can't process, for example, 1 terabyte and keep scalability property. So this table can help the user to know what is the requirement and which kind of system the customers can use. All of this, it depends on the requirement. For example, I can take another example about graph database. About graph database, it's difficult to process a social network data with relational database. For example, if you want to make a recommendation or to make some fraud detection in real time, it's difficult. So it depends on the requirement. It's just what I can say. Sorry, about this question. I don't know if I answer very well about it.
Yeah, I actually think you actually answered very well. If I may add, so NoSQL means not only SQL, right?
Yeah.
So it actually means that we are not stopping at query languages. We want to be able to extend to take care of other kinds of data, right?
Yeah,
And
yeah,
so,
right, Professor.
like you have said, the
Yeah, Professor.
requirement for the customer requirement should be the one that what it
Yeah,
is we can use. And
yeah,
I envisage that in providing solutions for our customers, it will have to take one or more of these and put them together to be able to have a viable solution. I think that's the way they can go around that.
okay, thank you.
Thank you very much.